The U.S. is undergoing a dramatic shift in power production, delivery, and usage. The energy transition is creating challenges to maintaining a reliable electric grid. Severe weather, electrification, the retirement of baseload coal plants, and intermittency caused by renewables are straining the grid. To meet the energy needs of the future, U.S. utilities need to add nearly 13 gigawatts of dispatchable peaking capacity to the electric grid between 2023 and 2027. But traditional peaker plants are expensive eyesores that can take years to build. The grid needs more flexible support. Introducing Enchanted Rock's Community Microgrids, a modular, sustainable, and customer-centric way to bridge the energy transition and meet the energy needs of the future. Unlike traditional peaker plants, which rely on a single genset located some distance from customers, community microgrids are localized energy systems that integrate multiple energy sources to provide grid support and reliable and sustainable electricity to a community or neighborhood when the grid goes down. Community microgrids offer several advantages over natural gas peaker plants. Lower emissions, easier siting, faster start, and flexible operation, greater availability and reliability, dispatchable capacity and local resiliency. Let's explore each. Lower emissions. Conventional peaker plants emit harmful amounts of nitrous oxides, sulfur oxides, and particulates into surrounding communities. With modern emissions controls and cleaner fuels, distributed peak generation will not have the same harmful impact on local air quality. In fact, Enchanted Rock microgrids emit 10 times lower emissions compared to peaker plants, and, with RNG, can be carbon neutral, helping you achieve your sustainability goals. Easier siting. Instead of one large power plant of perhaps 50 to 200 megawatts, the distributed approach spreads the same capacity across roughly 4 to 6 smaller plants. Without the noise and exhaust stacks that are noticeable from miles away, distributed capacity can be sited much more easily, often near existing distribution substations. And there is no transmission interconnection needed. Faster start and flexible operation. Gas and petroleum-fired turbines are the last resort when demand spikes because they use expensive fuel and are wasteful during long startup and cool-down phases. Smaller distributed sources can operate at full power in less than a minute or adjust output to efficiently follow load requirements. Greater availability and reliability. The chance of a single large peaker going offline inadvertently or even for scheduled maintenance is much greater than the chance that dozens of distributed resources will go down simultaneously during a peak event. Locating numerous sources of dispatchable power closer to the load inherently improves the overall risk profile of power generation. Dispatchable capacity and local resiliency. Distributed peak generation also provides backup power to commercial and industrial customers. Typically, these customers purchase their own expensive and dirty diesel generators for critical backup power. Utilities can better serve these customers and generate new revenue by putting them onto microgrids with distributed generating capacity that can be used as backup power during grid outages, in addition to providing peak capacity. Community microgrids can help utilities bridge the energy transition with more sustainable, customer-centric energy solutions that balance supply with demand. By embracing this innovative approach to grid modernization, electric utilities can meet the growing energy demands of their customers while reducing costs, enhancing reliability, and strengthening communities. Visit enchantedrock.com to learn more and speak to a microgrid expert.